Hello, welcome to Bradley's Maths video. This is video 1.3b, the second of three videos aimed at worksheet 1.3, prime numbers, highest common factor and lowest common multiples in the number for GCSE mathematics range. The worksheet is available on my website. Okay, what we're doing now is highest common factor. So what is a highest common factor? Well, if we have two or more natural numbers, we can find the highest common factor of them. That is the largest number that will divide into both both of the numbers. And we first express each number as a product of primes. We learned how to do that in the last video. Then we inspect the products, and any number which appears in all of the lists is part of the HCF. That last bit we haven't touched on yet, but you're going to see how to do it just about now. Okay, find the HCF of 18 and 30. Okay, let's do 18 in yellow. So I'm going to do it over here, and I'm going to do the factor tree, just to remind you of how we do the factor trees. 18 divided by 2, 2 is the lowest prime number, gives us 9. Yep, and 9 is 3 times 3. All the bottoms of the branches are prime numbers, so we have 18 equals 2 times 3 squared. Okay, I'm going to erase this just so I've still got room. Perhaps I should have done that a bit bigger, but never mind. There we go. Let's have a look at 30. 30, 2 goes into 30, 15 times, 3 goes into 15, 5 times. So 30 equals 2 times 3 times 5. Okay, now we're going to look for our highest common factor. HCF, highest common factor, equals. Now, let me use my highlighter. We have a 2 here and a 2 here. So a 2 is common. So 2. We have a 3 squared here and a 3 here. 3 squared is not common, but 3 is, because 3 squared is 3 times 3. So we have a 3 here and a 3 in here, and we put one of those in like this, 2 times 3, and we have a 5 in here, but we have no corresponding 5 in here, so 5 is not common to both sets of numbers. So our HCF is 2 times 3, and 2 times 3 equals 6, and 6 is the highest number that will divide into 18 and 30. 6 times 3 is 18, and 6 times 5 is 30. Okay. Now we can rub that out again. Give us some space up there. And press the wrong one. Where am I there? So Question 2. Find the HCF of 75, 90 and 360. Bigger numbers, no more difficulty. 3 numbers, no more difficulty. Okay, let's go through these. 75, we'll do 75 first, as that's the first on the list. 75 is not divisible by 2, but it is divisible by 3. And 3 goes into 75 25 times. 25 is not divisible by 2 or 3, but it is divisible by 5. And it goes into 25. 5 goes into 25 5 times. So we have 3, 5, and 5, a prime number at the end of each branch. Okay, so 75 equals 3 times 5 squared. Okay, let's get rid of that up there. 90. 90 is an even number, so it can be divided by 2, and 2 45s are 90. 45 is an odd number. It can't be divided by 2, but it can be divided by 3. 3 15s are 45. 15 can also be divided by 3, and 3 5s are 15s. And now we have, once again, we have a prime number at the end of each branch. So 90 equals 2 times 3 squared times 5. 90, not 9, 90. Okay, and 360 feels like a big number, doesn't it? But 360 will come down fairly quickly. And I'm going to do this the other way that I showed you, 360, for no reason whatsoever. I just think it's good that you know more than one way. 360 is 12 times 30. I think, no, it's not. It's 6 times 30. 12 must go into 360. I was right in the first place. It's 12 times 30. Okay. 12 is 3 times 4. And there's my first prime number. 4 is 2 times 2. 30 is 10 times 3. And 10 is 2 times 5. And what we have there is the prime factorization of 360, because 3 is prime, 2 is prime, 2 is prime, 2 is prime, 5 is prime, and 3 is prime. So we have prime numbers on the end of every branch. So we can say that 360 equals 2 cubed. There are 3 2's, 2 squared, 2 cubed. So it's 2 cubed times 3 squared times 5. And our LCM now, sorry, our HCF, our highest common factor, HCF. What's the biggest number that divides into 75, 90, and 360? So we look at our three sets of numbers. 2 appears in this one and this one, but does not appear here. So 2 is not common at all. So there are no 2's in the HCF. 3, 3 squared, 3 squared, the 3 is common. So our HCF, we can put equals 3 times, and then we have where's my pointer? 5 squared, 5, 5. There is a 5, at least one 5 in each one, and we can say that the HCF is 3 times 5, which equals 15. And that is it. That's all we have to do to find the HCF. Let's go and have a look at our LCMs and see what we can do with those. So this time I didn't mask the question off, I just left it as it was because I'm using exactly the same numbers. To find the LCM of two or more natural numbers, we first express each number as a product of primes. We inspect the products, and any number which appears in either of the lists is part of the LCM. Okay. 18, we said, was 2 times 3 squared. 30, we said, was, let me go back and have a look what we said it was. I can't remember. 2 times 3 times 5. 2 times 3 times 5. Okay. The lowest common multiple then, LCM. We have a 2 in each list. So the first number is 2. We have a 3 squared and a 3. So the 3 squared goes into the list. And this 3 here is part of this 3 squared. Just like this 2 is the same as this 2, this 3 is part of this 3 squared, but it's the 3 squared that goes in. Okay? And then we have a 5 here, no 5 here, but it's either list. Any number which appears in either list. So we have a 5 there, and our LCM is 2 times 3 squared. Well, 3 squared is 9, 2 times 9 is 18, times 5, and 18 times 5 is 90. 90 is the lowest number that can be divided by 18 and by 30. 18 goes into 90 5 times, 30 goes into 90 3 times. Okay. So the LCMs of 75, 90, and 360. I hope you'll excuse me if I keep jumping back to look at what they were. The LCM of 75 is 3 times 5 squared. So we'll write that down. 75 equals 3 times 5 squared. The LCM of 90 is 2 times 3 squared times 5. 90 is 2 times 3 squared times 5. And the LCM of 360 is 2 cubed times 3 squared times 5. 360 is 2 cubed times 3 squared times 5. So the LCM equals, all right, let's take this. We have a 2 cubed here and a 2 squared there and no 2 in there. We take the 2 cubed because that will include this 2. So 2 cubed. Then we have a 3 here, a 3 squared here, and a 3 squared here. So we take the 3 squared, which will include that one and that one. So we take this 3 squared here times 3 squared times, we have a 5, a 5, and a 5 squared. We'll take the 5 squared because that includes both of these. Okay, times 5 squared. So we have 2 cubed is 8, 3 squared is 9. What have I done? I put 52 there. Let's just get that right. 5 squared, not 52. And 5 squared is 25. And I'm going to bring, if I can find it, my trusty little calculator in. There's my calculator. I'm looking at 8 times 9 times 25 equals 1,800. 1800. 1,800. So the lowest common multiple of 75, 90, and 360 is 1,800. That is the lowest number that 75, 90, and 360 can all divide into exactly. Okay, that's it for this video. HCF and LCM finished today. In the next video, 1.3c, you will find some questions that you might like to have a go at on products of primes, prime numbers, HCF and LCM. Thank you for listening. Please take the time to like, subscribe, and leave a comment. Bye.